Here's one with fractions. We have negative 1/3 x minus 1/4 y plus z equals negative 9. 1/2 x minus 1/3 y minus 1/4 z equals negative 6. And x minus 1/2 y minus z equals negative 8. Okay, you don't want to do these systems of equations while leaving the fractions in. It's going to become next to impossible. It'll take you all afternoon, right? Instead, clear fractions, right? Use the clearing fractions technique. Clear fractions. Get rid of all those. Okay, what do I mean by that? What could we multiply both sides of this by to get rid of all the denominators? I'm looking at this top row here. To get rid of all these denominators, I could multiply this whole thing by 4. Right? I'm multiplying both sides here. If I multiply by 4, not by 4, by 12. By 12. That'll take care of the 3. That'll take care of the 4. And those are the only denominators we have. Similarly, on row 2 here, what can I multiply row 2 by to get rid of all these denominators? Well, we have a 2 and a 3 and a 4. All of those go into 12. So I'll multiply by 12 again. Down here, well, the only denominator we have is 2, so let's just multiply both sides on that one by 2. Alright, so let's see what that gives us. We have 4x minus, so I'm multiplying through in this first one by 12, minus 3y plus 12z equals negative 9 times 12 is negative 108. Alright, now I'm multiplying row 2 by 12. 12 divided by 2 is 6, so we have 6x minus 12 divided by 3 is 4, 4y, 12 divided by 4 is 3, minus 3z equals 6 times, or negative 6 times 12 is negative 72. Alright, and now we'll multiply everything down in row 3 by 2, giving 2x minus y minus 2z equals negative 16. And look, we have a new system of 3 equations, 3 unknowns, but there's no fractions in it. So let's work on solving this one here. We need to pick a variable to eliminate. What jumps out here is this y is all alone, right? No coefficient, which makes it really easy to multiply to get rid of the other two. So I'm going to choose to eliminate the y's, though you could choose other variables. It just might be slightly more work. Alright, so let's see. Row 1, row 2, row 3. Let's try to use row 1 here and do row 1 plus negative 3 row 3. What does that do for us? Well, that gets rid of the y's, which is what we want. Okay, so doing that gives, okay, so I'm just going to copy row 1, 4x minus 3y plus 12z equals negative 108. And then in row 3, I'm going to multiply everything by negative 3. Negative 3 times 2, negative 6x, times negative 3 times negative 1, so plus 3y, negative 3 times negative 2, plus 6z equals negative 3 times 16 is 48. Alright, add those up. We get negative 2x. The y's cancel out, that's what we intended to have happen, plus 18z equals negative 60. Okay. Returning back to our original one here, we still want to get rid of the y's, and now we're going to use row 2. Let's do this. Let's do row 2 plus negative 4 row 3. And that'll knock out the y's in row 2. Okay, so let's do it. Row 2, 6x minus 4y minus 3z equals negative 72 plus negative 4 row 3. I'm going to take row 3, multiply every term in it by negative 4. That gives us negative 8x plus 4y plus 8z equals negative 16 times negative 4, 64. Okay, add those up. We get negative 2x, the y's cancel by design, plus 5z equals negative 8. Okay, what we have created here is a nice system of two equations, two unknowns. One of them's here, one of them's here. Let's combine those into a system and work off that. So we have negative 2x plus 18z equals negative 60, and then we have negative 2x plus 5z equals negative 8. There's our new system. How nice, right? They're not too bad, because here we can simply multiply this bottom row by negative 1. How about that? We're going to get these, oh, this, I don't know why I have an x, a z here. That should be x. Okay. Now they line up nicely. Okay. I'm going to multiply this bottom row by negative 1, and then our x's will cancel right out. Okay, so doing that gives us negative 2x plus 18z equals negative 60, and then below that we have 2x minus 5z equals 8, positive 8 then. Alright, now we can add these two up. The x's cancel, that's by design, and for the z's here we have 18 minus 5, so that's 13z equals negative 52. Divide both sides by 13, that gives z equals negative 4. There's one variable down. Now, where do we plug back in? Well, we have a few options here. We don't want to go all the way back to the original. Actually, we're going to stay away from the absolute original because it has all those fractions in it. We don't even want to go back to this system up here because there's too many variables. We want to just go one level up. We know what z is, so how about we plug in right here? Okay, so plugging in right here. Do that in green. So we have negative 2x plus 5 times z we decided was negative 4 equals negative 8. Okay, negative 2x minus 20 equals negative 8. Alright, negative 2x equals, adding 20 to both sides gives us 12. So then x must be negative 6. X equals negative 6. There we go. So that, now we have z and x, and now we can go back up and plug in to get y. Alright, I'm thinking like this bottom row here looks like the easiest way. Again, you could choose any of these three, but usually you want to choose whichever one looks a little bit easier. So let's plug in here to this bottom one. X is negative 6, so we have 2 times negative 6 minus y minus 2 times z, which is negative 4, equals negative 16. Multiplying that one out, we get negative 12 minus y plus 8 equals negative 16. Okay, let's see here. So simplifying a little bit, we get negative y minus 4 equals negative 16. Negative y, adding 4 to both sides, equals negative 12. So y must be 12. Okay, and there's our answer, the ordered triple. we have -6, 12, and -4 for our answer.